Standard HTTP is great for fetching data, but if you're building a chat app, a live game or a real-time dashboard, require a response Java current. You need a persistent two-way street. You need WebSockets. Today we're implementing them in NestJS. Now we implement real-time communication by setting up a WebSocket gateway. This will allow our server to handle bi-directional data stream efficiently. First, we need to install the core dependency, NestJS WebSocket, NestJS platform socket.io, and socket.io. Once installed, we generate a dedicated chat socket module. This ensures our WebSocket logic is encapsulated and separated from our RESTful controllers. In chat.gateway.ts, we import some classes and interface decorators from NestJS WebSockets and socket.io. Then we implement the ChatGateway class. We use the WebSocket Gateway's decorator, passing a coarse configuration that allows our origin to ensure our client-side application can connect without handshake errors. To monitor the state of our server, our client implements switch key interface. OnGatewayInit, we use the after-init method to log that the gateway has been successfully instantiated. On the gateway connection, the handle connection method captures the incoming socket instance, allowing us to log the unique client ID upon successfully connection. On OnGatewayDisconnect, the handle disconnect method notifies us when a client terminates the session. We use the WebSocket server decorator to gain direct access to the underlying socket.io server instance. This is essential for broadcasting message to multiple clients. Next, we implement the after-init handle connection and handle disconnect to establish basic event logging. Finally, we define our event handler using the subscribe message decorator. Inside this function, we capture the incoming payload and use this .server.emit message payload to broadcast the data back to our connected subscriber in real time. To finalize our setup, we need to register the gateway and implement a switch to manage our data persistence. Open socket.module.ts here. We define a chat socket module using the module decorator. We import the chat gateway and add it to the provider array. This registration allows the NestJS IOC container to manage the gateway instantiation. Additionally, we add chat gateway to the export array, making our WebSocket logic accessible to other modules in the application. Next, we create chat.switch.ts to handle our business logic. After importing the injectable decorator, we define the chat switch class. For this demonstration, we implement a basic in-memory storage solution data structure. We initialize a private array to act as our temporary database. Method logic, we create a same-message function that saves a payload. This method puts the incoming data into our array and returns the data. Now that our switch is ready, we need to integrate it into our gateway and complete the application dependency tree in the chat gateway class. We import the ChatService and inject it through the constructor. By using private class access modifier, NestJS automatically initiates the switch instance, allowing us to access its method within our event handler. We define our primary event handler using the subscribe message, send message decorator. When a client emits a message, data persistent, we first pass the payload to this .chatService.serveMessage payload. The message is logged and stored before any further action is taken. Real-time broadcasting, once the data is processed, we use client.broadcast.emit message payload. This broadcasts the payload to every connected client, keeping the chat state synchronized in real time. To make this work, we must update our module configuration. Socket module and chat switch to the provider's array in chatsocket.module.ts. This makes the service available for injection into the gateway. App module. Finally, navigate to app.module.js and import the ChatSocket module. By adding it to the import array, you bootstrap the entire WebSocket logic into the main application lifecycle. With our WebSocket infrastructure fully established, we now verify the integration using a Flutter client. As soon as we launch the Flutter application, it initiates a connection request to our NestJS server. In the terminal, you observe an immediate log entry displaying the unique client ID. They confirm that the WebSocket handset was successfully and that the persistent bi-directional tunnel has been opened between the mobile app and our backend. To test the reliability of our Lifecycle hook, I restart the mobile application. Watch the server log closely. Disconnection. As the process terminates, the server triggers the handle disconnect method and log the event. Reconnection. Upon the app restart, the new connection is established and the server generates a fresh client ID. The similar cycle of connection and disconnection demonstrates that our gateway is correctly managing active sessions. We are now ready to stream real-time data between the NestJS environment and our Flutter UI. By following this step, you transform a standard NestJS application into a powerful, event-driven engine. We cover everything from scaffolding the socket module and defining gateway lifecycle hook to injecting service for data persistence. If this guide helped you bridge the gap between HTTP and WebSockets, please give this video a thumbs up and subscribe to the channel for more backend architecture deep dive. Now I have a question for you. Are you planning to use WebSocket for a real-time chat, or are you working on something different like a dashboard or a multiplayer games? Drop a comment below. I love to see what you're building and answer any technical question you have.